Okay, we're going to learn about using limits with limit notation, and this is a step that's involved in our work on finding the gradient of a tangent at a point on a curve, or what will soon be called the derivative. So make sure you've watched the previous videos. And the first expression we've got here is the limit as h approaches 0 of 22x squared plus 20xh plus h. So as h approaches 0, well, if you remember the diagrams, that's when that horizontal distance h gets smaller and smaller so that the length of the chord gradually approaches 0. And for that to happen, h has to approach 0. Now, you look at all the terms that involve h, all of those will be affected by this. However, 22x squared does not contain h, it is unaffected. So if you subbed in 0, those last two terms would be 0, and you'd have 22x squared. And so that's what happens essentially as h approaches 0. The limit, the ultimate limit of that is 22x squared. So it's a function. Second one we have here, the limit as h approaches 0 of 3x squared h plus 2h squared. Now ones like this, we don't want the h on the denominator, because we're subbing in 0 on the denominator, so we avoid that, and we can avoid it in a legitimate way by, in this one, by dividing everything through by h, because all three terms have a factor of h. So that would simplify as 3x squared plus 2h over 1, which I'm not going to write. So let me put the limit on that now. So basically we are finding the limit as h approaches 0 of 3x squared plus 2h. So the only term with a h on it is the final term. The first term there is unaffected, so we basically sub in, it's like subbing in 0 in a sense, so we would have 3x squared. So the last one here, we have a constant, so the limit as h approaches 0 of 4. Well, 4 is a constant, so constants are unaffected by changes. So the limit is 4.